In this video, we look at some different techniques for finding derivatives. So on this first problem, you're simply going to use the power rule on each term. Now, anytime we try to take the derivative of a constant, which technically does not have a power of x, that derivative is 0. And the reason is because if you think about it, if it doesn't have a power of x, that would be the same as it having a power of 0, because x to the 0 is 1. And if you apply the power rule where you pull it down to the front and multiply, you get 0 times whatever number is there, which is still 0. And 0 times anything is 0. So just always derivative of a constant is 0. Now, on the second term here, if we take the power of 3 and we pull it down to the front and multiply, we have what we think of it as a negative 7 times the 3, and then we have to decrease the power of x by 1. So we'll have a 3 minus 1, and I'll come clean that up in just a minute. And then on the next term, if we take the power of 2 and pull it to the front, we're going to be multiplying it by the positive 6 that's already there, and then we decrease that power by 1 as well. So on our final answer, 0 is just 0. When we multiply negative 7 times 3, we get a negative 21, and then we have our x. On the power, 3 minus 1 leaves me with the power of 2. Plus, when we multiply 6 times 2, we get 12. And then on our power, 2 minus 1 leaves us with the power of 1, which you technically don't have to show the power of 1. So that would be our final answer for the derivative. Now, on this second problem, they tell us to use algebraic techniques to first rewrite that as either a sum or a difference. So in this case, we need to use FOIL to write it out. So 2x squared times 5x squared would give me a 10x to the power of 4. On the outside, 2x squared times 2 would give me a 4x squared. On the inside, 5 times 5x squared would give me a 25x squared. And then finally, on the last, 5 times 2 would give me 10. Now, this is my original function f of x. So then they're asking me to find the derivative. And so notice the notation for the derivative has the little prime symbol. And so I'm going to apply my power rules to each separate term. So on the first term, when I pull the power to the front and multiply, 10 times 4, and then I'm going to decrease the power by 1, so 4 minus 1. And then on the next term, I'm going to say plus, take the power of 2, pull it to the front and multiply, so that becomes 4 times 2, and then decrease that power by 1. And then on my next term, plus, I'm going to take the power of 2, pull it to the front, times the 25, so 25 times 2, decrease that power by 1, and then finally, the derivative of a constant is always 0. Now, you could have, if you wanted, you could have combined these two terms first before you did the derivative, or you can combine them afterwards, which is what I'm going to do. So 10 times 4 will give me a 40, and then this is x to the third. 4 times 2 gives me an 8, and then that leaves me with x to the first. 25 times 2 gives me 50, and then that leaves me with x to the first, and then I have a plus 0. So on my final answer, I have my 40 x to the third, plus, when I combine those, a 58x, and that is my final answer for the derivative. On this third problem, they're again asking me to use algebraic techniques to rewrite it as a sum or a difference. I am going to split apart my fractions. So my original function f of x, I have a negative 5x cubed on top. I'm going to divide it by x squared. And then I'm going to say minus, I have a 6x to the fourth on top. Divide it by x squared. So when I simplify that, I'm left with just simply a negative 5x. Notice if you subtract their powers, 3 minus 2 leaves you with an x to the first on top. And then I have minus, it's going to leave me with a 6x squared. And again, if you were to subtract their powers, 4 minus 2 leaves me with a power of 2 on top. So now, with this particular function, f of x, I am going to apply my power rule for derivatives. Okay, so on the first term, it's understood to have a power of 1. I pull it to the front, and I multiply it by the negative 5, and then I decrease that power by 1. And then I have a minus 6. I'm going to pull the power of 2 to the front and multiply it by the minus 6, and then decrease that power by 1. So when I get ready for my final answer, negative 5 times 1 is negative 5, and then you're left with x to the power of 0, and then we have minus 12, and you're left with x to the power of 1. X to the power of 0 is always just the same as the value of 1, so it's not normal to write it as x to the 0. We're just going to say this is just negative 5. And then we have minus our 12x, and again, we typically don't show the power of 1, so that would be our final answer. Okay, on this next problem, we are being asked to first find the slope of the tangent line at a given value of x. So in order to do that, we have to first find the derivative. And so if I have, I'm just going to put the function over here. If my function is 3x cubed minus 9x minus 6x squared, the first thing I want to do is use my power rule to find the derivative. So again, I'm going to take the power, pull it to the front, and multiply. 3 times 3 is 9. Decrease the power by 1. So notice I'm starting to not show that middle step there, and you too can do that. And then I have minus. My power is a 1. Pull it to the front, multiply it by 9. 9 times 1 is 9. And then when you decrease that power by 1, you get x to the 0. But remember, x to the 0 is just 1. So you would just have minus 9. And then minus, take the power of 2, pull it to the front. 6 times 2 would give me a 12. And then when you decrease that power of 1, it would just become x. Now, for the slope of the tangent when x is equal to negative 5, you're simply going to plug the value of negative 5 in for x. So you're going to have a 9 times negative 5 squared minus a 9 minus a 12 times negative 5. So this becomes a 9 times 25 minus a 9, and then that becomes plus a 60. All right, 9 times 25 would be 225, and then minus 9 plus 60. And then 225 minus 9 is going to leave you with 216. And then plus 60 is going to give me a slope of 276.